So today I would like to discuss information protection and data security in general. So today we live in a very connected society where each one of us is generating a lot of data and consuming a lot of data at the same time. So the consequences of that is once in a while we'll come across situations where our personal lives, our professional lives, our educational lives, all those data will have to be stored somewhere. So in that case, if we lose access to the data or someone else gets the access to that data without our consent, there are dire consequences. So protecting the digital data is kind of at the heart of the data security, but I will mostly focus my talk at the end of this definition, which is basically data breaches as opposed to cyber attacks and other things. Okay, so as opposed to giving you a very technical overview where we are discussing the functions, the methods, or the techniques that we can use to prevent data breaches and data losses, I'll kind of give a brief overview and a bird's eye view of the information protection agencies and information protection pipelines that are used by all the big corporations today. So my goal here is to enable you with a set of steps that are simple but can be created inside your own silos and your own ecosystem so that you can protect your own consumers' data. Because wherever we have these cloud services where we are collecting information from the user, we will have to, today or tomorrow, create some sort of data protection policies. And doing that has multiple challenges, some in engineering area, some challenges are in technical area, some challenges are in from the perspective of the users as well. So I'll discuss all of that and give you a few simple steps that you can do to protect the consumer's data. And finally, I'll give you a little bit of lessons learned from my own experience. I have I'll discuss a little bit of my history before I go into those lessons learned part. So I graduated from University of Dhaka, and then I went to University of Nebraska-Lincoln to do my master's and PhD in computer science. After that, I joined Microsoft, and I did about 8 years of tenure there. I worked 6 years in Microsoft Office 365 information protection team. So recently, about 4 months back, I came back to Bangladesh and joined Shohoz. Before that, I was working into the information protection and data loss prevention teams of Microsoft Office. So if you guys are using Word, Excel, PowerPoint, Microsoft Teams, or Outlook, so all of these products, my team had some footprints, and I actually was fortunate enough to write a lot of code and build the frameworks that runs the data loss prevention for in this software. So what happens today? When starting from cradle to grave, today most of the advanced countries and the developed nations have defined different ecosystems and different points of entries for collecting your data. So when you're born, they will collect the information about your blood types, your family history, and your lineage, and the time of your birth, all those things. Then all the information that you generate, the emails that you send, the documents that you create, those are all considered intellectual property and belongs to your office. So the organization will probably get hold of those and keep it alive even when you are not there. And also the views you have, and say you like a certain political party, you like a certain aspect of religion, or you don't like either of those, and you post those views online, maybe in Facebook, in Twitter, or in other social media. So if it is public, some people are able to read it and maybe store it and get some kind of definition about what you are thinking and what your choices in your lives are. And finally, education. When you are graduating from a school, your GPA records, your if you had any suspensions or any kind of other issues that came across your life, they will collect it, and most of the universities and educational institutions like Pearson, ETS, they will actually create a record of you and a kind of a profile of you. When you apply to colleges, they share that amongst themselves. So the point here is people are actually defining you based on all the data that you are producing today. So maybe you are just using an app, an innocent app, to send an image to your friend, but if you have not read that agreement with that app, they might actually be collecting that information and storing it in the back end server. So, for example, the national services in Scotland, they have created this cradle to grave pipeline and diagram of exact all human beings that are born in there, and then they will collect the profile information and then they'll store it in the medical database. So all of these type of definitions have profound impact on how you live your life. If you know, there is a famous movie called Gattaca. I don't know if anyone has seen that movie. So in that sci-fi, they show that just because a person is born with certain genetic traits, they will collect that information and profile that person for the rest of his life. So whatever things he can do, the jobs he can apply to, all of those are predefined just because his gene pool actually has some specific encodings in it. And the premise of that movie is that does the data about your gene defines the kind of person you are. So it's an interesting movie if you can check it out. So not all the data that are being collected today are kind of the same nature. So there are regular data, like maybe you're getting an invitation for a wedding from your friend, and there are some personally identifiable data, for example, your username, the websites that you're visiting, your phone number, your ID card number, all those things that can actually pinpoint who you are and where you are working or doing some activity. And then there are specific sensitive information like your credit card information, the transactions that you are doing. So depending on the types of the data, we have to make sure that we maintain the right type of access for different types of data to protect the user's privacy. So today in the industry, people define the sensitive types of data in kind of a specific nomenclature. So we have the PII, which is the personally identifiable information. So this is something that can, from your transactions or your actions, that can identify who you are and where you live or what type of work you do. Then there is this professional health information, which kind of allows you to link a person's health history to that specific person. So if you can find out what type of disease he or she has and what type of medications they are currently taking. And then there are financial information like credit card information, which is, if it is linked with your personally identifiable information, you can right away steal money from somebody else. So which a lot has happened recently. And finally, there are these political and religious information that if you look at our country's history, we have had lots of issues with Facebook, people posting offensive images, or maybe someone posing as somebody else and posting images on their behalf and creating lots of chaos and riots and other issues. So if you, I was just trying to see the type of data breaches that recently happened. So there are lots and lots that are happening every day, right? And I'm sure that a lot of the people who are today here might have had some of the information stolen. The Cambridge Analytica one, where they stole a lot of Facebook users' information, I was part of that. And the Equifax, when I was in USA, there was the Equifax breach on the lower right-hand corner. where they stole the PII information of about 143 million users. I was in that list as well. So as we get into a more developed society and more connected society, the more likely it is that we will at some point face these sort of issues where the information that defines us is stolen and then somebody can get access to it and then do harm to our personal and professional life. Okay, so what are the consequences? One of the consequences is that your own money, your own reputation, and your own personal life will get impacted in very badly and in very negative ways. And also, if you look at national level, if you look at how Cambridge Analytica exposed those data and created a false campaign in USA's election, you will see that they were able to create a huge political movement where those users were following Donald Trump and they were creating rallies for Donald Trump, whereas they were actually driven by some Russian operatives who were not even in USA. They were not even US citizens. And they didn't know that. They thought they were following someone who's living next door and following their political philosophy and ideology. So what are people doing today to prevent those kind of attacks or harms from reaching us? So if we, unfortunately, most of the small companies do not have the sufficient resources to attack these sort of problems. An organization should have some kind of data protection policy, and the big corporations like who maintain a large, maybe 100 million users or more, they are kind of bound to do this in most of the countries, in developed countries like in Europe and in USA. But in smaller companies, it's sometimes very difficult to implement because it requires a lot of engineering resources. So, for example, in Europe, they have this GDPR. When I left in the last few months in Microsoft, they were forced to comply with the GDPR compliance, where we had to rewrite a lot of code in the entire Microsoft ecosystem, in the Office 365 specifically, where we were making sure we never expose PII or PHI data ever in any logs, any reports, any transactions. And the breaches, once that happens, is the fines is extremely harsh. Like they will fine Google or Microsoft about maybe 2% of their profit for that entire year if they have a breach all over the world. So it is like Google actually paid about $2 billion for one of the breaches, and then Microsoft kind of said, okay, we need to do something about it and not pay that $1 billion. So they kind of hired a lot of people to address that. And as we grow the software industry in our country and we ship software abroad, we will also have to comply with this, because otherwise, if they find any fault in EU, the consequences will be dire. There are other smaller, different sets of compliance rules as well. California, I don't know if you guys are aware of this, has one of the biggest economies in the world, the state of California in USA. And they have their own compliance rule, same as China. So if you are shipping software there or allowing users in those regions use your software, theoretically, by law, you are supposed to follow these compliance rules to protect their data. So who are providing you those tools? Today, Symantec has a nice set of tools. So does Google, if you do the Google data protection policy. And then there is a company called ForcePoint. They provide end-to-end solutions. So if you have data in a database or a cloud storage, you can hire them to sanitize and go into those storages and sanitize and protect those data from intrusion and accidental leakage. And finally, Microsoft has adopted the information protection ecosystem, where they have Windows information protection, Azure information protection, and Office information protection. So if you purchase those licenses and you install Windows in your operating system in your machine from which is given by your organization, your files, your content will automatically be secured. If you create a Word document, it will get secured. You cannot just share it outside the boundary by default. So they have created a lot of checks and balances so that you do not accidentally lose data or share data. So why do people want to invest in this? Basically, information protection or data loss prevention, where we are preventing data breaches by accident, is becoming a booming industry, because anyone who provides a solution for these sort of problems are going to make not millions but billions of dollars. So Microsoft has kind of discovered that a little bit late, so they are trying to play catch up. Symantec, Proofpoint, these companies have already created very solid solutions and shipped them across the world, and they are earning them. Okay. So how do we do information protection? So say you have your own company today. You have a specific customer base who are creating software product, or maybe you have an e-commerce site where people are coming in, doing credit card transactions, buying stuff and getting it shipped to their home. What are the steps that you need to do to protect that information? The first is detecting. So we have to basically manually and programmatically audit all the sources of information. So how are we augmenting our database? What are we adding to those databases? Who are the users who are inputting and giving their personal information into our system? So basically going through your entire ecosystem and coming up with a short checklist of all the areas where data is coming into your system will be the first step. The next is classifying. So this is an interesting problem. So how say you have a billion records in a database which contains multiple lines of text and sometimes maybe numbers. How do you classify what is information, what type of information should be protected and is sensitive and what is not? So usually there are naive approaches like just running a regex person and allowing yourself or the users define what is sensitive. For example, if you have a credit card number, we know that they have a specific pattern. So it will be like maybe a MasterCard will be like a 444 or 446, something like that. So then with that information, you can scan the fields of the database or the user inputs to ensure that you know what is sensitive and what's not. Another way is that you allow some sort of offline parsing. When the data is already stored in your system, you create automated jobs that goes in and analyzes that stored data, the cold data, and then flags them by itself. The next step is, what do you do when you detect that there are classified information that is getting leaked outside the org boundary? Say I am sending an email with all the customer data, maybe their credit card information, to my colleague. But say the address I'm using is a public domain, regular gmail.com account. So what will happen is, if you have this information protection in place, we should be able to catch that in flight. So before the email is actually delivered to the inbox, we will be able to scan it and say, this matches the pattern that we have already discussed as sensitive, which is the specific credit card number pattern. So we cannot let this email go through. One thing to notice is that we are trying to prevent accidental leakage. If someone tries to actually send it, we are not able to stop it. That is not part of the information protection. That will be some kind of attack or malicious activity. So that will be kind of a little different. And once we detect it, what do? We can block that email or block that document from getting outside your org, or we can say, let's maybe just apply encryption so that the person that it is intended to can only read it. So either way, we are making sure that this information, piece of sensitive info is not getting breached and getting to somewhere on the public internet where someone else can read it other than the actual intended receiver. And finally, monitor. So this is a crucial part, because any mid-sized organization will have maybe hundreds of users, and we need to always make sure that we know who's doing or sending or leaking information, or maybe intentionally or not unintentionally. So basically having generating reports or some kind of monitors that would alert us or the alert the system admin is a very necessary step for any information protection. So if we have, like, just to give you an example that how do we generate and detect data. So if we have maybe say 100 million users in a like an email service provider company, and then we have maybe 1 megabyte of text that we are sending each on average for each of those users. So we'll basically end up with at least a terabyte of data. So the challenge here is scanning and classifying that huge amount of data every day, day in, day out, without failure. Because when someone makes a mistake, they just have to be right once. But when you are trying to protect that information, and you will have to be right every time, all day long. So it's a very difficult engineering problem to achieve maybe 100% or close to 90% accuracy, because any mistakes that you make will have some kind of cascading. So classification. So what we can do is like we can create AI models or text models, document fingerprints that kind of shows the type of data that should be considered sensitive in our system, and then we allow that system, the AI system, to go and parse and check the data that is in transit or the cold data. So then you will not have a specific pattern, but you will have some kind of model that it will give you some predictions based on the input that you are giving it. Another thing is actually, which is very often overlooked, is the manual labeling. If you have been using Google Mail or Outlook, you will see you have a way to label those emails now. So those auto labeling, if you allow users, whether it's an email service or if it's someone, an admin who's going through your user records, if they label some data, if they have a way to label your the rows in your database or transactions, and then flag them as sensitive, if you have a learning system in the back end, they will be able to learn from those levels and then apply those learning into preventing data breaches. Okay, and finally, user specified. Here you can actually, the users can manually create classifications and give a feedback. So what happens, say the system creates a classification and then it flags an email or flags a specific user input as sensitive. Then the user can give a feedback to the system that the AI model that is used is actually not working very well. So the data that it flagged that it is sensitive, actually it is not. So that feedback can be put into the back into the system and then improve the model of that classification. So how do we, the next step is, once you identify and classify, how do you protect the information? So if right now most of us use the mobile phones a lot, we have store documents, images, and then share that on the phone all the time. So basically most of the big corporations are trying to prevent leakage through those phones by creating some sort of policy on those phones, like that your phone needs to be password protected or encrypted, so that if you lose it, you're not losing the entire organization's sensitive info on that phone. Because if someone gets hold of your physical phone, it will take them maybe a few minutes to extract the information out of it. Then drive encryption is another one, where all the info from your organization that is stored on that mobile device becomes encrypted. So even if you lose your phone, someone will not be able to decrypt that and read that out unless they have your credentials. And finally, a lot of the organizations are creating using a service called Intune, which allows you to remotely wipe the mobile phone of your employees if someone loses the phone or leaves the company, something like that. so that you do not have control over whether you are taking that organization data away with you or not. So how do we protect the data that is not on the mobile phones? So encryption is basically one of the easiest way to do it. If we encrypt all the data that are stored at the company level, for example, when you're storing data in your data processing pipeline, say you have a lot of data coming in databases and you would like to parse and sanitize that data and create AI models. But the AI models that you are going to create will not need the PII information. So if you can create some encryption or one-way hash, you will be able to still create that pipeline and you will be able to create those models, but not expose that data to someone in your company who should not look at it. So encrypting and hashing the PII and PHI data, that is something like a very common practice. So DLP, so the DLP is basically a process which is a subset of the information protection steps, where you create smaller policies that target specific groups for their actions when they're interacting with your system, whether it is your backend database or it is your reporting system or your data pipeline, which will prevent them from reading data which is not required. So if you are working as a data scientist, you do not need to go and read data to figure out the PII for each of those records in the database. Once you detect the data, the next step is to notify the user, notify the administrator, so that we know that how many of these breaches are happening and how do we prevent it. And finally, once you are done your work and a specific detention period has gone by, say you have left the company or the user have left your system, so then your system should be able to remove those old data, because keeping some data for a longer period of time when the user is not associated with your organization can create very serious data breaches. So once we have some kind of data breaches, what we do is like create some monitors and allow some kind of alerting to happen, so that the administrators and the users themselves, if you are following GDPR, you will also have to notify the individual users that their data have been breached. So one important part of this monitoring is that we will always have to revise and retune our policies. Whatever policies you make today is not going to be relevant tomorrow. So that is something that actually our team learned after a few years of working with customers in Europe. So, excuse me. So what are the lessons learned from my experience in the data loss prevention and information protection team? The naive data based on regex matches is actually very computationally expensive. So when you're running, if you remember the example that we're running it on terabyte level data or petabyte level data, writing code that runs in distributed system on that scale and that does regular expression matching is extremely hard to maintain, because we always get some edge cases where the regex defined creates some sort of loop, and that's all it takes to bring 1, 2, or 5 machines down. And like I said, when you are trying to create a system which does information protection, you have to be right all the time. If you just miss one instance, that might actually be enough for data to leak out of your organization. So AI and ML techniques are very difficult to scale. So in our team, we actually created an AI pipeline where the customers are able to create, AI ML rules. However, when we released that software to regular users, what happened was for them to create the model and train it took them months and months of time. So if just having that opportunity does not translate to actual data protection, because you will need a largely scalable team of data scientists who can help the customers to create those sort of rules. Incidents. So if you assume whoever is here today, assume today, right now, you're breached. Someone has grabbed hold of your database with all the PII information. So in that case, what would you do? If you are given only 30 minutes to work, right now, can you go and stop it? Or do you have the set of steps ready to address those issues? Can you block access, stop the bleeding, notify the customers? So all those things, if you assume that you're breached right now, that is the starting point. And then you can figure out how ready you are today. So that is an exercise that pretty much all the big companies do once in a while, that they will assume the data has been breached all of a sudden, and then they will monitor what people are able to do to stop that leak. And finally, you need to educate the users. If someone is continuously creating Excel files with all the users' credit card information and posting everywhere, data loss prevention can only work that so much. So user education and how data is sensitive is also really, really critical of reaching that information protection step. So today, I think I was looking for some suitable code about data, and I found this one by Tim O'Reilly, is that today the data is becoming more and more critical than the software itself. Because the software code is generic, it does a specific functionality for everyone. But the data actually defines who you are and what you do. So if we cannot protect what's important, it is guaranteed that at some point in your life, you will face consequences because of that. So I think this is information protection and data loss prevention is something we should always think about in our country's perspective when we are building cloud systems or large scale systems. Yes. That's it. Thank you very much. We'll take